All right, so far we've done some examples of solving systems using substitutions. We have two more where the solutions turn out to be a little bit different. So we're going to go ahead and look at example 5. We are solving the system 2x plus 8y equals 7 and x equals 11 minus 4y. Now keeping into what we already did before, we always go to the equation that's solved for either x or y. The second one is solved for x. I'm going to go ahead and star this one. Okay, and then I generally like to box what x equals. X equals 11 minus 4y. All right, so since this says x equals, that means x is coming out of the game. So we'll go up to the first equation and we'll scribble off the x. So now I'm going to start writing this first equation. When I get to the x, I will substitute. So I'm going to get the 2. I'm already to the x. So now I'm going to substitute with 11 minus 4y and then just continue writing that statement. Plus 8y equals 7. Now I'm just going to simply solve for y. So I'm going to distribute. 2 times 11 is 22 minus 2 times 4y is 8y. Plus 8y equals 7. All right, now notice something kind of crazy is going to happen here. When I go to combine like terms, negative 8y plus 8y is nothing. So I just end up getting 22 equals 7. So notice my y's drop out. So basically what that's meaning is that there is no y left to solve for anymore, and I just get an equation that says 22 equals 7. 22 definitely does not equal 7. So what we just found out was that there is no solution to the system of equations. And basically what happened, it doesn't matter what we plug in for y, this will not ever work, which means if you were to graph it, these two lines would be parallel. So that's what we get when we have no solution. If we were to graph it, that's what would be true. Okay, example 6, we have y equals 3x minus 5 and 9x minus 3y equals 15. And again, we're going to star the one that's either solved for y or x, which in this case is the top one. It's solved for y. And then I always like to box what y equals. Y does equal 3x minus 5. Then I go into the other equation. Since I have a star by y, I'm going to scribble off the y because y is going to be substituted. So now I'm going to just rewrite that second equation, 9x minus 3. And then instead of the y, we are going to put 3x minus 5 in its place. And then it still equals 15. And now we're just going to solve. I'm going to distribute the negative 3, so I'm just going to drop down the 9x. Negative 3 times 3x is negative 9x. Negative 3 times negative 5 is a positive 15, and then equals 15. And just like in the example 5, the variables are going to end up dropping out because 9x minus 9x is just 0. So I end up getting 15 equals 15. So notice this time there's nothing left to solve for, but this time I have a true statement. 15 does equal 15, which means instead of having no solutions, I will have infinite solutions. Every number that I could possibly think of when I plugged it into both of those equations would give me a correct answer. And what that means, if I were to graph them, I'd have a line, and when I went to graph the second line, it would graph right on top of the other one. So they coincide, so there are infinite solutions.